Good morning, guys. Today we're going to be looking at dividing polynomials, and in the process we're going to be using factoring. There's another method we're going to go over next time called synthetic division, and but right now we're going to look at factoring. Okay, so far, this past test that we took, we've learned how to add, subtract, multiply, and factor polynomials. So today we're going to look at how do you divide, right? Because we're going through each of the operations, right? Adding, subtracting, multiplying. Factoring is one operation that's specifically for polynomials, and then today we're going to look at how to divide polynomials. There are three methods that we're going to learn about in this class, but today we're going to start with one of the first methods called factoring. So we're going to divide by factoring. Okay. So here, let me zoom out a little bit more. Okay. So here we have, when you're dividing, usually you put the division symbol like this, 1 divided by 2. But you can also write it as 1 over 2. So we'll be writing the division as fractions of, an expression divided by another expression. So an expression on top of another. So some examples that we'll see are something like this, where you have an expression on top divided by an expression on the bottom. Since we're writing our polynomial quotients as fractions, we will simplify the polynomials the same way we do with fractions. Okay, so you remember when we were asked, to reduce fractions, you look for a number that can divide both, right? These are both divisible by 3. So 9 is 3 times 3, and 24 is 8 times 3. So these 3's cancel, leaving you with 3 over 8, right? So this is reducing the fraction. So we're going to be doing kind of a similar idea, but instead of with numbers, we're going to be dividing expressions or factors. Right, so we're going to need to factor and then check to see if anything cancels out or divides out. Since these two divided out, we're left with 4 divided by x minus 5. Okay, so that's one thing to remember about dividing and how we're going to apply it to expressions. And one other reminder, fractions are undefined if the denominator is equal to 0. Like, for example, if you say 3 divided by 0, if you type that in a calculator, it's going to say error because you cannot divide by 0. So when we're dividing polynomials, we have to identify any values for the variables in the original expression that would make the denominator equal to 0. So I'm going to show you how that looks like when we work out examples. But those are a couple things we want to remember about dividing. All right. So as far as steps go for factoring, there's 3 main steps. Right? First, we want to factor all the numerators and denominators completely. So you want to look at, if you have a fraction, you want to look at the top and the bottom of the fraction. Right? Numerator is the top, denominator is the bottom. So let's write that out. So we have numerators is the top of the fraction. The denominator is the bottom of the fraction. And so we want to factor the top and the bottom of the fraction completely. Then step 2, divide. Divide out common factors of the numerator and denominators. Again, divide out the factors of the top and the bottom. And then step 3, identify any restrictions for the values of the variables. Identify any restrictions. So restrictions are any value that makes the original rational expression undefined. So any value that makes the denominator equal to 0. So I'll show you how that looks like. Basically, when we divide everything out, we're going to check to see if there's anything left on the bottom. If there's anything left on the bottom, as far as x's go, we're going to check to see when they're equal to 0. But I'll show you what that looks like when we work out an example. There's 6 examples to look at. So let's just go straight into them. All right, so example number 1. So the instructions say divide the polynomials by factoring. Identify any values for which the expression is undefined. Show all your work. So we're going to factor the top and the bottom, and then we're going to divide out anything in common. Okay, so for example, in this one, we're going to, let's see, I'm going to do the steps this way. So we have 6 over x to the 7th and 9 over x to the 4th. Right? So we have the same way as saying, I can say 6 is 2 times 3, right? And I have how many x's on top, right? 7. 1, 2, 3, 4, 5, 6, 7. Then divided by, let me draw that a little bit straighter. Divided by 9 is 3 times 3, and then I have 1, 2, 3, 4 x's. So what's going to cancel out, right? 3 divided by 3 cancels out. Then I'm going to cancel 1, 2, 3, 4 pairs of x's. So that's going to leave me with 2 over 3 times, notice that all the x's on the bottom cancels out, right? So I canceled 1, 2, 3, 4 pairs, and I'm left with how many x's? 3, so it's x to the power of 3. That is my answer. So I wrote out all the x's, right? But basically, when you're dividing variables with exponents, you want to think of subtraction. What's 7 minus 4? 3. See, there was 7 x's on top, 4 on the bottom. You cancel 4, and then you're left with 3. Okay, so let's look at example 2. Let me see if I can zoom in. I'll try and zoom in a little bit more just to focus on the spacing and the size. Okay. So let's say, okay, I have example 2. Then we want to factor the numerator and denominator. But more, check to see what we can factor. So let's say I'm looking at the numerator. So the numerator, again, is everything on top. So think about it as like a problem that we've done in the previous chapter. Remember, we were looking at GCF. So if you're looking at the GCF, what would you say is the GCF for the top? just the top part, what I circled in blue. So that part, you can divide the 15 and the 24. They're both divisible by 3. What else can we say? They're both divisible by 3. Do they both have r's at least? Yeah, they both have at least one r. So 3r. So what do we usually do, right? We take, for example, if I have 15r squared minus 24r, that's everything on top, right? We would take this value and divide it out on the bottom, right? But what would we write over here? Over here I'm going to copy the 12r on the bottom. Just copying the 12r on the bottom. And then on the top, we would set up our parentheses and put 3r in the front. Put the GCF in the front. So divide. What's 15 divided by 3? That's 5. Right, this goes over here. 15 divided by 3 is 5. What's r squared divided by r? It's r minus, right, bring the minus. What's 24 divided by 3? It's 8. R divided by r will cancel. Okay, so this is factoring out the GCF on the top. Right? Now, on the bottom, can we say, as far as the 12 goes, isn't 12, so let me copy the top. Isn't 12 4 times 3r? So we can say this cancels with this, the 3r and the 3r. So that leaves me with 5r minus 8 over 4. Yeah, and so that would be it. That would be my fraction. Right, because the 3 and the r. So here I could also do, that the r's are going to cancel. You could say that these r's will cancel, and 3 over 12 is 1 over 4. Or you can do this. You'd say, can you divide 12 by 3? Yeah, 4 times 3. It's going to cancel these, right? The 3 and the r. Okay, so that's an example like that, like 2. Okay, let's look at example 3. Zoom in again. Okay, and so this time we're going to look at the denominator. Check to see if the denominator has a GCF. Well, it looks like the 12 and the 9, they're both divisible by 3. And they both have at least one m. So what would we usually do, right? If I copy the bottom, 12m squared plus 9m, we usually take this GCF and divide it out on both terms. So I'm going to put equals, put my fraction line, copy the 3m to the third, just copy it, bring it over, and then this red part is where I'm getting the GCF from, right? The 12 and the 9 are both divisible by 3, and they both have at least one m. So I'm going to write the GCF is 3m, and then I'm going to set up my parentheses. And so what's 12 divided by 3? That's 4. M squared divided by m, it's m, plus, what's 9 divided by 3? It's 3. And then m divided by m cancels. All right, and then let me zoom out a little bit. Then over here we can see that the 3's are going to cancel. Let me use it. Yeah, that's fine. These 3 are going to cancel. And then here, if I have 3 m's on top and 1 on the bottom, this is going to cancel with this, and it's going to leave me with 2 m's, so m squared. So my final answer is going to be m squared over 4m plus 3. So that's my answer, but there's a process that we haven't gone over yet because it hasn't come up. But the idea is, if I look at the denominator, I want to check, when is the bottom going to be equal to 0? So basically what we're going to do is we're going to, let me slide over here. So let's say I have my answer, and one thing I'm going to do is write the denominator, but set it equal to 0 and solve for m. So if I solve for m, I'm going to subtract 3 on both sides. Let me choose a different color. These are going to cancel. Bring down the 4m equals 0 minus 3 is negative 3. And then divide by 4 on both sides to get m by itself. So these are going to cancel. And so m is equal to negative 3 over 4. Okay, so notice I'm just taking the denominator, the bottom part of the fraction, 4m plus 3. I'm writing it and I'm putting it equal to 0. And then I'm just working it out to solve for m. Okay. And my m value ends up being this. So what I'm going to say is m cannot. So notice that I put equal. I put equal with a slash. That means cannot equal negative 3 over 4. So that's my last step here. Okay, let me just put a reminder that this means cannot equal. So this symbol means cannot equal. And what I'm basically saying is that the bottom, the value of m cannot be negative 3 over 4, because then it's going to create a 0 on the bottom. Okay, we're going to practice it again, but problems like these are going to have two answers. You're going to have the fraction as your answer, whatever you get when things cancel out. And then once you get your fraction, you take the bottom part of the fraction, put it equal to 0, and solve for m, and that's going to be the last process. And then you're just going to put cannot equal this value, because it's going to make the denominator 0. Okay, so let's look at another example and let's see if the similar process comes out. So we finished example 3. Just zooming out so we could get the whole picture. You know, if you want to pause the video, you can. And so let's go over to example 4. So let me slide over. Oh, one thing I almost forgot. Notice that we didn't do the same process. You know, this process that we did for example 3, where I put the bottom equal to 0. Here it can't work in example 2 because the bottom doesn't have a variable, a letter. Example 1, we had a denominator, but it only had a 3. It didn't have a letter on the bottom. So let's look at example 4. What's going to happen in this one? So again, let me zoom in. We can focus on the problem. Okay, so here, let me zoom out. Actually, here we're going to work out the top and the bottom. So we want to try and factor the top and the bottom. Okay, let me make sure. Kind of trying to decide. I want to get like a large perspective on it. Okay, so I'm going to copy the top part over here. And then I'm going to copy the bottom part over here. So I have the numerator and the denominator. But it's kind of like two problems from the last notes, the last lesson. So for the problem over here on the left, we should notice that I'm going to be using the table method. So I'm looking for 2 terms to multiply to give me, there's a 1 here. So I'm multiplying 1 times negative 15. That gives me negative 15. Then the value in the middle is negative 2. I'm looking to add. Okay, so 2 numbers that multiply to give me 15. I can do 2 times 5. No, sorry, 3 times 5. But it can be negative 5 times 3 is negative 15. Right, that's a check mark here. And then what's negative 5 plus 3? That's negative 2. So I get a check mark here. Right, so then I set up my parentheses, but let me erase this a little bit. So I'm going to put my parentheses down here. So my parentheses are going to be following, and it's y, y, and the numbers that worked were minus 5 and plus 3. Okay, and then on the part over here, well, actually, let me put this on the top. So I'm going to say that this is equal to, I'm going to set up my fraction, my two parentheses on the top are going to be y minus 5 and y plus 3. Right, because I took this from the top and I used the method from last class to help me figure out what it's going to factor out into using the table method. And so I'm going to write that on, copy this up here. Now I'm going to work on the bottom. The bottom is like a difference of two squares. So what would I usually do in this part, right? I would say, can I square root the first term? Yeah, that's a y, so checks off. Then I would say, can I square root the last term? I would say, yeah, that's a 3. So this is my A and my B, right? And then I would say, oh, if it's a difference of squares, it's going to be A plus B times A minus B. So that's going to be y plus 3 and y minus 3. So this is going to go, right, y squared minus 9 became y plus 3, y minus 3. Y plus 3, y minus 3. Okay. So I'm working out this problem. This gives me y minus 5, y plus 3. I copy that on the top because that's what it worked out to when I factored using the table method. Then using this other method, I got that y squared minus 9 becomes y plus 3, y minus 3. And then we should notice that there's some cancellations happening, like this is the same as this, right? So these will cancel. So that's going to leave me with y minus 5 on the top and y minus 3 on the bottom. So that's one answer, right? But let's not forget that I still needed to take the bottom. Y minus 3 is the bottom. Set it equal to 0 and solve for y. So add 3, these cancel. Y equals to 3. But remember, we're going to put cannot equal to. So again, we take the bottom, y minus 3. We put it equal to 0. We solve for y. And then we say that y cannot equal 3. What happens if y equals 3? Well, if I plug it in, what's 3 minus 3? It's going to give me a 0 on the bottom. So we don't want the bottom to be equal to 0, but it's going to be equal to 0 if it's 3. So we're saying y cannot equal to 3. Okay? So that's the conclusion for example 4. So again, I ended up with two answers, right? The fraction and the part that's telling me that it cannot equal to a certain number. Okay, so then let's look at number 5. And we got kind of an idea. So let's write out. I'm going to write out 2n squared plus 10n, and then over here do like a 3n squared plus 16n plus 5. Okay, so in the top part, right, this is the top, 2n squared plus n. Do I have a GCF? Yeah, both 2 and 10 are divisible by 10, and both of them have an n. So what do I usually do? I take this GCF and I divide it. And I write out the GCF parentheses. Right, so 2 divided by 2 cancels. N squared divided by n leaves me with n plus 10 divided by 2 is 5, and n divided by n cancels. So over here, this is going to be equal to 2n n plus 5 divided by, okay, so the top part, this 2n squared plus 10n, became this. So I'm going to write it out on top here. Now let's look at the bottom. The bottom looks like a table method question. So that means I'm going to set up my table. I'm multiplying and adding, right? I'm adding to get 16, and I'm multiplying the 3 and the positive 5 to give me 15. So I want to multiply to get 15 and add to get 16. So it's going to be 1 times 15 is 15, and 1 plus 15 is 16. Okay. And so we set up our parentheses, and we say the variable is n is positive 1 and positive 15. But keep in mind that the number in front was 3. So we need to divide both of these by 3. It's going to give me n plus 1/3. And n plus 15 divided by 3 is 5. So this is going to change to 3n plus 1 and n plus 5. All right, so all of this on top became 3n plus 1 times n plus 5. So I'm going to copy that on the top over here. So it's 3n plus 1 times n plus 5. And what do you know? What do you notice on this fraction over here? You know, again, the top part, this 2n squared plus n became this. So I copied that up here, replaced it, right? Then the bottom part, which I wrote over here, I used the table method and then the bottoms up method to become this. And so the bottom changed to this. But then we should notice that there's an n plus 5 here and an n plus 5 here. These are going to cancel. So that's going to leave me with 2n on top and 3n plus 1 on the bottom. But remember, what do we do with the bottom? We copy the bottom, set it equal to 0, and solve for n. So we subtract 1, 3n equals negative 1, because these are canceling here. Then we divide both sides by 3. These are going to cancel here. And n cannot equal to negative 1/3. And there we go. That's example 5. So notice that, we're doing the factoring from the previous lesson. We're doing the table method and the factoring from the previous method. And we're doing all this, we're factoring the top part of the fraction, we're factoring the bottom part, and we're checking to see, does anything cancel? That's the whole purpose of factoring, is to kind of simplify things overall. As we go to different newer and newer lessons, this factoring is going to come along and come up again. Okay. So let's do example 6. Hopefully we're getting the hang of it. So in example 6, if you notice, there's no GCF on the top. Well, there's one thing that we can do. Can I write the top like in the following way? Okay, can I write the top like this? Yes. So if I write the top like that, then I would say, yeah, then there is a GCF. There's a GCF of -1. And so what do we usually do with this GCF? We divide it. We divide it out. And so we do something like -1 parentheses. What's negative m divided by -1? It's positive m. What's positive 12 divided by -1? It's -12. Okay, so that's the top part over here, m minus 12. And you'll see right now, after we work out the bottom part, but you'll see right now why we did this, right? We make sure that it's written in standard form, right? Because m to the power of 1 is bigger than m to the power of 0. So when I write it in standard form, it's going to be -m plus 12. Then we say, okay, the GCF is 1, but since the first term is negative, I'm going to say -1 is my GCF. So we divide it out and we get the following. Now, let me write down the bottom part of the fraction. That's m squared minus 144. So just copying the bottom over here. And we should see that it's a difference of squares. Can I square root m squared? Can I square root 144? Yeah, the square root of m squared is m. The square root of 144 is 12. So yeah, both of them can be square rooted. This is my a. This is my b. Difference of squares says I have to set it up as a plus b and a minus b. So it's going to be m plus 12 and m minus 12. So copy that on the bottom over here, m plus 12, m minus 12. Right, so the bottom, which was this, using the difference of squares, became this. So I copied it on the bottom. And then we should see that I have m minus 12 on the top and m minus 12 on the bottom. So these are going to cancel. So it's going to equal to -1 on top divided by m plus 12 on the bottom. But what have we been doing with the bottom, right? We copy it, copy the m plus 12, set it equal to 0, and remember, we're eventually going to put cannot equal to, right? So the bottom, the m plus 12 cannot equal to 0, so we solve for m. This 12 and this 12 cancel, so we end up with saying m cannot equal to negative 12. All right, so this is my fraction and this is my restriction. So that brings us to our last example. If you have any questions, I'll be going over it in class next time. But thank you for joining me. Have a great rest of your day.